Okay, so we are on page 9. We didn't finish this part yesterday. So fractional exponent, that means when you see the exponent being a fraction, not a integer, then we can predict whether the graph is going to be odd or even. First, before you do anything, you always want to simplify the fraction. So you always want to simplify the fraction. If that fractional exponent is something you could simplify, you always simplify. The second thing is that once you simplified it, you are going to check the denominator first. There are only two things that can happen. One is the denominator is going to be even. The other, the denominator is going to be odd. Okay, so if the denominator is odd, we're going to check the numerator. If the numerator is also odd, it's going to be odd function. If the numerator is even, it's going to be an even function. Okay, second case. If the denominator is even, you still want to check the numerator. If the numerator, okay, so let's kind of look at some of the cases. All right, so before we kind of go too long with all these like scenarios, let's look at possibilities. So you have x to some kind of fraction. You always check the denominator first. So let's say it's 5. 5 is odd, so you're going to check the numerator. Let's say that the numerator is 1. Is this function going to be odd or even? Odd. What does odd mean? Yeah, flip over 180 looks exactly the same. That's what odd means, okay? Now, if the number is 2, then it's what? Even, so something like this, right? So both sides are looking the same, so across the y-axis. Now, what happens if the denominator is even? So let's say it's the denominator is 4. Well, let's see. There's a few things that can happen. If that number in the numerator is even, that means you didn't simplify, right? Even means you didn't simplify. Obviously, it is always true. Even means you at least can divide by 2. So if the numerator is even, you need to simplify. You didn't simplify enough. You couldn't really look at what the denominator and numerator really are. So you got to simplify. Let's say the numerator is not even. Let's say that it is 1. Okay, so now we have to talk about what is going on. Well, x to the 1/4 is not a recognizable function you've seen before. So let's try something else. A normal even denominator that you usually see is 2. And then a normal numerator that's odd is 1. So then you have x to the 1/2. X to the 1/2 looks like what? No, this is not x squared. X to square root x. Square root x. Okay, square root x looks like this, right? Is there a left-hand side to this? No. Why not? Because it can't be negative, right? X cannot be negative, right? You have a square root x, you can't square root negative numbers. So that basically this is true of every single thing that has a even root. Because even root means you cannot put negative x inside. So all of the ones that have an even denominator and an odd numerator will only show up on one side, because the other side is always undefined. Does that make sense to everybody? Okay, so if the numerator is odd, we will only have one side, because the denominator being even means it's an even root. Even root cannot have negative numbers inside. All right, so this is only positive x values. So it's neither even nor odd because it only has one side. The graph only shows up on one side. All right, so let us kind of summarize. You really only have three cases. Odd denominator, odd numerator, odd function. Odd denominator, even numerator, even function. Even denominator, odd numerator only show up on positive side. And then the last one, obviously, you didn't simplify. All right, let's practice. 1, 2, 3, 4. Even, odd, or neither. Okay, even, odd, even, and then last one is even. Any questions? Yes? Oh, yes. So what you want to do is change it to a fraction. So then that's going to be 1 over 5. So then 5 being the, yeah. All right, so that's the last part of yesterday's lesson, and we're going to go into 2.3, and then we're going to spend 2 days on 2.3 because it's one of those that you really have to know because once you learn 2.3 and 2.4 really well, most of the time you don't need your graphing calculator. You can predict how the graph will look like, which is preferred way of doing these things. All right, so let's talk about polynomial a little bit more. Polynomials can only have positive powers, positive exponents. So that means we don't have any x in the denominator. All right, so let's look at some general graphs of a monomial. X to the first. X to the first looks like what? Yes, straight line, very good. All right, so it's gonna look like this. Let me put some lines here. Okay, x squared. How does x squared look like? Parabola. Yes, very good. X cubed. How does x cubed look like? Like this. Right hand's going up, left hand goes down. Yes. And then x to the 4, you probably don't know, but something else. Yeah, something like this again. So what you want to do is let's look at the end behavior, or the two ends of this graph. It's kind of interesting. There is a pattern to this. So x to the first will only have one turn, straight. X to the second will usually have two turns, 1, 2. X to the third, this is a very simple one, but if we add more terms, it will have more turns. It goes 1, 2, 3. And then x to the fourth, we can predict it's going to go 1, 2, 3, 4. So it always goes with the actual exponent. That's why we can predict how things will look like. So again, x to the first looks like this. 1 turn, 2 turns. X cubed usually has 3, but this is a very simple one, so it doesn't. Usually it looks like this. And then we can predict x to the fourth is going to look like 1, 2, 3, 4. Now let's look at the end behavior a little bit. We kind of talked about that a little bit yesterday. We said all the odd ones look alike, all the even ones look alike. And you can see that it is true. All the odd ones start from the bottom, goes up. All the even ones starts from the top, goes down. Okay? Yes? All right, so let's kind of guess. How will x to the fifth look like? Where is it going to start? Is it going to start on the top or the bottom? The bottom, because it's the fifth degree, it's odd, right? All right, so fifth degree, let's kind of make a guess. X to the fifth. So we said it's going to start on the bottom, and then how many turns do you think it's going to have? 5. So it goes 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. Does it actually look like that? We don't know, but at the very most, it will have 5 turns. Okay, let's make a guess of x to the 10th then. X to the 10th. where is it going to start? On the top or the bottom? Top, because it's even, right? All right, how many turns the most it will have? 10. Okay, so then we can say that looks like this. Starts on the top. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Goes back up on the top. Even function. Okay, so we don't know how this is actually going to look like, but at the most, it will probably look like that. All right, so kind of summarize all that. So here's some characteristics about these functions. Odd functions will start from the bottom, goes up. So we're going to say start from the negative infinity, goes to infinity. Even function will start on the top and end on the top. So they're going to start from infinity and goes to infinity. The number of turns is related to the highest degree, or the maximum number of turns is related to the highest degree. So 4 degrees means 4 turns, and so on. The number of maximum extrema, maximum local extrema. Maximum. All right, so let's take a look again. X to the first. How many local extrema does it have? None, right? X squared. How many local extrema does it have? 1. Yeah, 1. If this one actually didn't make a turn, like 1, 2, 3, like that, x cubed, how many extremas will it have? 2, okay? X to the fourth, how many extremas does it have? 3. So then what's the rule here? 1 less, yes. 1 less than the highest degree. So that is the maximum number. Will it always be that number? No, because that's just the maximum possible. So it's always going to be 1 less than the highest degree. All right. And the fifth one, you already know. The number of zeros is the same as the highest degree. So, this is the polynomial rule, right? Or the fundamental theorem of algebra, that the number of zeros has to do with the highest degree. Okay, now let us graph some things. You're going to graph, next page, sorry. You're going to graph x cubed, I forgot this again, squared. Okay, x cubed and this function in the same graph. Okay, so using your graphing calculator, graph it in the same graph. You're going to see how they are related to each other. Okay, so basically if we zoom out enough, we can see that they look pretty much the same. Therefore, what happens is the highest degree is going to dominate the graph. So if you want to predict how the graph looks like, just look at the highest degree. That one is always going to dominate the graph no matter what. The rest of it is too small to be looked at. Okay, so this shows us that the leading term meaning the one with the highest degree, is going to dominate the behavior of the entire polynomial. So we almost pretty much don't care about what's going on with the other ones if we just want to look at end behavior. All right, so let's do some practice. All right, predict the end behavior of these polynomials without graphing them. Just predict them and write the end behavior using limits. Okay, let me know when you're done. All right, so if you look at 1 and 2, the highest term is going to dominate. So the first, number 1 is odd. Odd means that you're going to start on the bottom and goes up. So limit as x goes to negative infinity, f of x goes to negative infinity. Yep. And then limit as x goes to infinity, f of x goes to infinity. And number 2, x to the fourth is going to dominate, so that's an even function, both points up, but there's a negative, so it points down. It's going to flip over. Okay, so limit as x goes to infinity, f of x goes to negative infinity, and then limit as x goes to negative infinity, f of x goes to negative infinity. All right, now can you try this? Draw the most accurate picture of this without decimals or your graphing calculator. Okay, well, let's do it together. What should we start? Trey's giving me this hand motion.
Start from the bottom.
Start from the bottom and goes up. Why?
It's odd.
It's odd. Very good. So definitely we know that the two ends, no matter what, is going to look like this. We just don't know how it looks like in the middle. What can we do? How do we figure out what's going on in the middle? P over Q. Why do we want to do P over Q if we want to do P over Q? Not really P over Q. We need to factor. Yes, we do need to factor, but why? That will give you the zeros. At least we'll know where the zeros are. Huh? This one doesn't really have a vertex. Yeah. So yes, we are going to factor. Huh? Yeah. Yes. Yeah. We were finding the x values, which is finding the zeros. So you remember how to factor? Huh? Zeros? Roots, zeros, x-intercept. Yeah. They all mean the same thing. Do you remember how to factor this? This is a 4-term grouping.
Yeah.
Yes, we're going to do grouping. So kind of review from last year. If you don't remember, just kind of look at the notes from last year, how to group. So basically, you are going to, oops, sorry, let me erase this. Cannot do it. You're going to group and then take out the greatest common factor and all that stuff. I hope you still remember. If not, you can ask your partner. Your partner will probably remember. Your partner doesn't remember. There's someone next to you that will remember. Okay, go ahead and factor. You should get how many factors? 3. Very good, because that's the highest degree. All right, try it. Okay, so if you don't remember how to factor, please check your notes from last year. Okay, so you're going to group. So you're going to take out the greatest common factor, which is x squared. So that's x plus 2. Take out a -1 from here. So that's x plus 2 again. X plus 2 happening twice does not mean you have 2 x plus 2s. It means that you can take out x plus 2. And then you're left with x squared minus 1. So now you factor again. You're going to get x plus 2, x plus 1, x minus 1. So then your roots are x equals -2, -1, 1. So if you put those on your graph, -2, -1, and 1. Sorry, 1. Ooh, sorry. 1. Okay, we can connect them together, and we know that because it's x cubed, it's going to have 3 turns at the most. So probably something like this. So it goes up 1, 2, 3. I know the connection was not that great. 1, 2, 3, like that. Okay, let's try another one. Predict how this graph will look like. So factor this. You get x times x minus 3 times x plus 2. So then x is equal to 0, 3, and -2. So if you were to predict this graph, first you put the zeros on there. 0, 3, and -2. And then we know the end behavior is going to look like an odd function. So this goes down, this goes up. In the middle, it has to have 3 turns. So 1, 2, 3. Okay, let's try another one. This one. Okay, so this one first, you look at it and you say, oh, it's x cubed because there are 3 degrees. So it's going to look like an odd function. And if you look at the zeros, x is equal to 2 and -1. There are only 2 roots because one of them is repeating. So if you were to draw this graph, you would have a root at -1 and then a root at 2. You know it has to look like this because that's the 2 ends. The problem is, how is it going to connect? is it going to, because it has to have 3 turns, right? So it goes 1, 2, 3. So is it going to be this way, 1, 2, 3, or this way, 1, 2, 3? Because, okay, so is it this way where you connect on the top and say 1, 2, 3, where you jump on 2 and then you don't cross it anymore? Or is it, let me change it to another color, like this, where you go 1, 2, 3, where you jump or, kind of jump off of -1. No matter what you do, whichever one you choose, I'm going to tell you which one is the correct one. The very worst thing you can do is 1, 2, 3. You just decided to cross somewhere else. This makes no sense. You only solved for 2 roots. You crossed another place. Does that make sense? Because I see this on tests a lot. They forgot how to connect them. They just wanted to make it connect. So then they connected somewhere else. So that would be really, really incorrect. Please don't do that. Now, how do you know which one is the correct one? Is it the red one or the yellow one? Some of you already learned this before, so you did it correctly. Well, there is a rule, obviously. The rule is if you have a repeated zero, repeated zero means that it's, has a multiplicity. So we talked about that last year, multiplicity. And in this case, it's 2. Then we would say x equals 2 is a zero of multiplicity 2. Now, when there are multiple of the same factors, multiplicity, we say multiplicity m. So you would usually just write m equals 2, meaning there are 2 of the same thing. So if it's going to be odd, meaning that there is only 1 or 3 or 5 or 7 of that same root, then it's going to cross the x-axis. And if it's going to be 2 or 4 or 6, basically it's an even number, it's going to bounce off. Okay, so in this case, 2 is my double root. -1 is my odd root because it's just, there's only one factor. So at -1, it's going to cross. At 2, it's going to jump off. So this is, the red one is the correct one. Okay, so remember, if it's odd numbers of factors, it's going to cross. If it's even numbers, it's going to jump off. Let me see if there's a practice. Let me just have you guys practice one, and then we will be done for today. So let's practice this one. Y equals, let's do a weird one. Negative x minus 3 squared x plus 1 times x cubed. This is very extreme. So go ahead and graph this one. Count how many degrees it should have. Which one is going to bounce off, which one is not. Talk to your partner, work together so you can solve this one. So 6 degrees, okay? -1 is a 0, 0 is a 0, and then 3 is a 0. There are 6 degrees, so it has to be even. So either both of them are up or both of them are down. It is negative, so both of them are going to point down. So I usually draw the end first and then try to connect them. So basically it's going to look like this. It's going to cross here because it's odd as well. It's not going to cross here because it's even.